Hello, so today we are going to do this problem, which is part of Leetcode weekly contest 316, minimum number of operations to make arrays similar. So we get two arrays, nums and target, and in one operation we can choose two different indices, okay, that are between 0 and the length of the array, of course, and for one of them we can add 2, the other one we subtract 2. So that's one operation, adding 2 to 1, subtracting 2 from 1. And what the goal of what we want to accomplish is getting the minimum number of operations to make the array numbers similar to target. And by similar, it means just that the frequency of each element is the same in numbers and in target, in nums and in target, right? Now we are guaranteed to have an answer, right? So it's always possible to make nums similar to target, so we are guaranteed to have an answer. The arrays can be really long, 10 to the power of 5, so we can't really do like trying all options or doing an n squared solution. So let's see how this would work. So for example, in this first one, we want to make this similar to this one. So we can choose for the first operation, we can pick 0 and 2, and so add 2 here, and subtract 2 here. So that leaves us with 10 and 4, okay? And then in the second operation, we can pick 1 and 2, this one and this one, and then add to this one and subtract from the other one. So we have 14, 2. And that way we have 10 ones, 14 ones, and 2 ones. So now they are similar because it's the same frequency for each number. If we take a look at the second example, well, we only need one operation. We can pick these two and add 2 to 2 and subtract 2 from 5. So we will end up with 4 and 3. And that's the same frequencies in both arrays. Okay. These are already equal. So already have the same frequencies for 1, which is the only element here. So we don't need to do any operation. We return 0, right? So that's the idea. Now, how can we solve it? Okay, so let's see how we can solve it. So the problem says that it is guaranteed that it's possible to turn nums to target, right? It's possible to have the same number of occurrences, to make the same number of occurrences of each number in nums match those in target, right? So let's think about a couple of observations that will help us here. So we know that you can only convert an odd number in this list number to be another odd number from target, to match another odd number of target, because you can't convert an even number to an odd number using just +2 and -2, which are the only thing that the operations allows us to do. With just +2 or -2, you can only turn an odd number to an odd number or an even number to an even number. So that's another observation here. The other one is that since we are guaranteed that this is possible and you can only turn a number to another one with the same parity, then obviously for this to be possible, we have to have the same number from each parity in nums and in target. So we need to have the same number of odds in nums as the same number of odds in target. And similarly for even, the same number of evens in nums needs to be equal to the same number of evens in target. Okay? So what does this mean? That means that to turn nums to match target, the number of increments of odd plus the number of increments of even is equal to the number of decrements of odds plus the number of decrements of even. Why is that? Because we are guaranteed that this is possible and we have only +2 and -2 operations, right? So we need to pair every +2 with every -2. So we need to pair every increment with a decrement, and we need to pair every odd from nums with an odd from target. So this has to happen for this to be possible. Okay. Okay, so now we know this. So what we can we do then is, instead of doing like every pair of operations with a +2 and -2 for every 2 indices, let's just do the total of increase for odds that we need to do, the total of increase of even that we need to do, the total of decrease of odds, and the total of decrease of even. And then once we get everything, we can divide it by 2 to get the answer, right? Why divide it by 2? Because we'll pair every 2 operations here with each other, because we do each operation, we do +2 and -2. Okay? So now the answer becomes, how do we minimize the number of operations? We know how to get the operation, but how do we make this minimal? The answer is we need to sort. So first, since we want to do the odds and evens separately, we need to filter and get only the evens of nums and evens of target, and get only the evens of here 1, 4, 5, 6, and then maybe we have a set of other elements, or let's actually just limit it to this, and 2, 3, 7, 8. Okay, so we separate into evens for n and t, and odds for t, and for odd and even for nums and target, right? And so we get them in sorted order, and so we pick the smallest and see how many operations it takes us to get to 2. So 4 minus 2, that's 2, right? And then 6 minus 2, that's 2. So overall, we need 2 here means that we need to subtract 2 once. And this here means we need to add 2 once, right? So you can see this is just one operation, right? An operation being like a half an operation. So remember, an operation is +2 or -2. And so one portion of an operation is just 1 by subtracting 2 here. Another portion is just 1 by adding 2 here, right? So what this would mean is that each time we will add to our count, we'll add the difference, so the absolute value of the difference, let's say from num minus the value in t, divided by 2. Why divided by 2? Because we are either adding 2 or subtracting 2, okay? But why is it better to take the smallest ones from n and from t? Because let's say we don't do that. Let's say we don't take the smallest. So maybe pair 4 with 8 and 6 with 2. So how many it will take to get 4 to 8? Well, it will take adding 2 twice, right? So 2 portions of our operations. For 6 minus 2, it will take adding 2, subtracting 2 once to get 4, and then subtracting 2 again to get 2. So it will take, the difference is 4, it will take 2. So overall, the difference is 8, but it will take 4 portions of an operation here. So comparing 4 and 2, it's better to take this 2. And you can try it with other bigger examples, because when you take the smaller of the 2, the difference will always be smaller than if you've taken it with a bigger number, right? So that's the idea here. And this, you can call this argument a little bit exchange argument. So that's why we pick the smallest. If we take a look also at the odd case, we for just 1 and 2, the difference is 1, right? For 5, sorry, not 1 and 2, we have to do 3 here. This was a mistake. We have to do 3 because it's only odds. So 1 and 3, the difference is 2. 5 and 7, the difference is 2. So here, 1 portion of an operation, 1 portion of an operation. So here, it's the sum is 4, but 2 operations. Let's say we don't pick the smallest. We pick the 1 with 1 larger and 5 with 1 smaller. So we do 5 minus 3 and 1, 7. So 5 minus 3, that gives you 2. So 1 operation, right? Just subtracting 2 once. 1 and 7, well, that gives us 6, right? Okay, so 6 is like adding 2 3 times, okay? So this is like 6, 7, 8, so 8. So it's adding 3 2 times. So here it's like 3 times. So overall, this is 4. So you can see it's bigger, right? So we know that we need them sorted, and we know that for each one, it's just a portion of the operation, and we will be doing count plus the absolute value of num minus t divided by 2. This 2 is from the +2 or -2 we do in an operation. And then once we are done, we need to divide the count by 2, because when we were counting here, remember, we did just 1 portion. We counted just 1 portion for adding or subtracting 2. So we need to, so we counted each operation twice. So we need to divide by 2 to get the actual number of operations, right? So that's pretty much the idea here. Now let's just summarize a little bit here so that we make sure it's this is understood. So what we are doing is we are guaranteed that it's possible to turn nums to target. And we know that for that to happen, we need the increments of odds plus the increments of even to be equal to decrements of odd plus the decrements of even. This is because we'll pair each increment with the decrement, right? And that's what allows us to do the divide here. And then the other thing we are greedy argument that we are taking is that it's always better to convert a number, the smallest number of n, to the smallest of target, of course respecting the parity, right? Because you have to turn odd into odd and even into even, and so that's why we separate here. And then for each count we just take the difference, divide by 2, because we'll be either adding 2 or subtracting 2, and then total, and then at the end divide everything by 2. So that's pretty much the idea here. Now let's code this up and make sure it passes test cases. Okay, so let's code this solution. So the first thing, we need to sort both arrays, numbers and target, and then we need to get the n evens, right? And we need to get the target evens. So for here it's just x for x in nums if x is modulo 2 equal to 0, right? And here is just similar thing except it's in target. Okay. And then we want to do also a similar thing for odds. So this would be odds, and this is odds, and all we need to change is it needs to be equal to 1. Okay. And now we'll start doing first for the evens. So our count starts at 0, so the number and then the element in t, and we want to pair these together, the smallest with the smallest, so we can use zip for that. You can also just do like I, right? Maybe that's easier for you if you want to just do I in a range of the length. Okay. In that case, we need to take the absolute value of the number from n evens minus the number from t, the target evens, right? Maybe I need to make this like properly named variable. So t odds, and then we take from n evens and from t evens, right? And we divide by 2 because each time we'll do either +2 or -2 operation, right? And then we want to add this to count, and we do the same thing for the odd values. So this is just n evens. Okay. And this would need to be n odds, and we have n odds here as well, and t odds. So we do the same thing for odds as well, and then at the end we just need to return count divided by 2. So let's run this. Let's try more examples, and let's submit. Okay, so that passes test cases. Now, in terms of time complexity, this is at most over n. We have at most over n numbers. Same thing here. So overall, it's over n time. In terms of space, we are going through the array here and here. We are using n evens and t evens, which have at most size n, so over n space as well. So over n for both time and space. And that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.